Welcome to Mighty Spriggles. Let's explore Earth's hidden heat. Today we'll learn about geothermal energy, Earth's natural heat. Geothermal means heat from inside our planet. This heat lives deep under the ground. Earth stays warm on the inside all the time. A lot of that heat sits in hot, squished rocks. Earth's center, called the core, is super hot. Some heat is leftover from when Earth was born, long ago. More heat comes from tiny bits in rocks that slowly make warmth. These tiny bits are spread through Earth's inside layers. Together, they gently warm huge areas of rock. In some places, that heat warms underground water. Over time, heat moves outward toward the ground. It travels slowly and makes steam, hot springs, and geysers. In towns and fields, geothermal heat lies just below the ground. This naturally occurring subsurface heat is called geothermal energy. Earth's interior supplies continuous heat from planetary formation and ongoing radioactive decay. It is present day and night, year-round, and strongest near tectonic plate boundaries. In high-temperature areas, steam and hot water erupt as geysers. Hot springs discharge heated groundwater to the surface. In quieter regions, shallow subsurface temperatures remain stable and usable. Availability and temperature depend on local geology and depth. Over geologic time, heat migrates upward through rock by conduction and convection. Conduction warms overlying rock. In some zones, magma and fluids convect upward. Water circulates through fractures and porous layers, forming hot aquifers and steam reservoirs. Harvesting the planet's warmth begins underground. Engineers access heat through drilled geothermal wells. Rigs bore into hot rock, and the reservoir's heat drives water to the surface as high-pressure steam or hot brine. In some fields, this heat naturally vents as hot springs or fumaroles. Most developments use paired wells to extract heat while maintaining reservoir pressure. Insulated pipelines route the fluid to the plant, where separators condition the flow for power conversion. Dry or flash steam is directed through a turbine, turning the blades and shaft to convert thermal to mechanical energy. The shaft drives a generator to produce electricity. Afterwards, the cooled water is re-injected to sustain the reservoir. For moderate temperatures, a binary cycle uses a second fluid that vaporizes, spins a turbine, and condenses in a closed loop. Did you know the ground under your feet stays cozy all year round? We can use that warmth to heat our homes with something called a ground source heat pump. In winter, special pipes buried underground soak up the Earth's heat and bring it inside to keep us warm. In summer, it works in reverse, moving heat from the house back into the cool ground. It's like a super efficient air conditioner. We can also use the Earth's deep heat to make electricity for whole towns. These geothermal power plants create clean energy day and night, which is much better for our air and our planet than burning fossil fuels. This amazing Earth heat can even help grow food in greenhouses all year long. Making power from the Earth's heat is a big job, and it's important to do it safely. So, how do we protect our planet while we do it? Sometimes the hot water from deep down brings up minerals or stinky gases. Special filters clean the steam, and the leftover water is sent back underground to keep everything tidy. Moving all that water can make the ground wiggle a little. Scientists use special sensors to watch for this. They use a traffic light system. If the ground wiggles too much, a red light tells them to pause and let things calm down. They also work hard to protect animals and nature nearby. By watching carefully and using smart science, geothermal energy can be safe for everyone, for a long time. Section 5. A future warmed by wisdom. Geothermal's next phase is driven by engineering advances and improved subsurface mapping. Researchers are targeting deeper, hotter resources. Enhanced geothermal systems, or EGS, create permeable reservoirs in hot rock that lacks natural water. EGS drills into hot, dry formations, stimulates flow paths, and circulates water to extract heat for electricity generation. In modern grids, geothermal complements wind and solar as a stable, dispatchable resource. It provides firm, 24/7 power that supports reliability, fills variability gaps, and reduces reliance on fossil peakers. Hybrid portfolios pair geothermal with wind, solar, and storage to deliver clean, reliable, cost-stable energy for homes, hospitals, farms, and schools. Progress relies on responsible practice. Careful siting, closed-loop fluids, re-injection, and continuous monitoring. Benefits include efficient heating and cooling, dependable electricity, cleaner air, and reduced local impacts when well managed. Earth's heat is a long-lived resource. With prudent stewardship, it can serve communities for generations. Please like, share, and subscribe to Mighty Spriggles channel.